with this in mind, going back to our presentation, and let's take a look at examples of how strings can be constructed. So here, instead of using namespace std, we can say using this particular thing. And so here, string s1, an empty string is constructed, the string with no characters. Copy constructor can be used, like construct string 2, an exact copy of string 1. Construct class instance s3 and initialize it with hello. So we can construct strings from C-strings. So let's refresh our memory on C-strings this time. All right, so given all this demonstration with what we already had, let's say that, okay, if this string was initialized with hello, okay. So what happens is that the C string is simply the characters hello, each character here, gets stored somewhere in memory, but the C standard says that any string literal is automatically terminated by the 0 character. Essentially, the character encoding that contains just 0. All other characters have non-zero encodings. The result of us saying quote hello close quote is that this allocation takes place and the pointer to the first character is returned from this expression hello, right? So the result of this is that we get pointer to the first character. And therefore, this particular constructor of string, which takes C string as its parameter, what it does is that it basically gets pointer to the first character, and it will scan the entire string, find the terminating null character or the character with 0 encoding, and will store the actual string, this part, inside the string class. So this and this are two different things. This is a low-level C-style string, which is terminated. Sometimes they're called C strings or zero terminated strings. Whereas this is a class. So if I go to build, right, build this, and if I right-click here, given that we have an expensive compiler environment here, we can say, okay, take me to the definition of this, right? So somewhere in the header file, here's basic string, right? Basic string, which is even longer template with multiple template parameters, and define it as string. So let's go to definition of basic string, and it's a template class, basic string, and so it has a lot of those type defs inside, and eventually it goes and declares all these constructors, which do something useful, right? So it's just a class, a C++ class, which is defined someplace, and we use it to create our own objects, our own instances of this class. Okay, so just to be clear that this is very different from what string is. Why strings are useful? Strings are useful because this is immutable. Once you have this hello, potentially I could do something like that. Character pointer p-char equals hello, right? So first I capture a pointer to character, and then I initialize my string with this pointer to character. It's the same thing, right? So instead of giving hello directly to my string, what I do first is that I capture a pointer and then pass the pointer. So once I have a pointer, I can get to individual characters. For example, all of them can be accessed through index notation, as if this was an array of characters, right? So all characters here could be numbered, index 0, 1, 2, 3, 4, and there's even 5. That 0 terminating character is also present there, right? So all of them have index. So if I say pchar1, I'm referring to character hello. So it's okay for me to display it, like cout display this character, except that, of course, I need to include IO stream to get access to cout, right? So I can do this. However, I cannot do this. Take like this H character, the first character here, character with index 0, and change it to a lowercase version. This I cannot do. Let's try to compile this. So it compiles first. It compiles fine, because what happens is that I'm going to tell you this little story after we run it. If we just run this program, Control F5, the program crashes, right? So it stopped working, blah, 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 and all that. It crashes because allocation of this memory goes into the constant memory segment. That's what compiler does. Any string literal, any allocation of characters done like this is immediately becoming a read-only memory. However, this is an acronym that is inherited from the C programming language. It's C++ still, as you can see, allows us to initialize pointers which look like modifiable or pointers to modifiable memory, and initialize them with non-modifiable memory. In reality, what I should have done here, I should have said that this is a const. Once again, pchar is a pointer to a constant character. That would be essentially a safer and advisable way to create such pointer, which points to hello. That way, compiler already knows that this cannot be compiled. So anyway, so this sort of demonstrates the idea that C strings are immutable. Once defined, you can define them all you want. They become immutable strings. They're defined somewhere in the memory. They allocate memory. They're stored in memory, but you cannot use them as variables. You cannot change them. They're just read-only objects, read-only sequences of characters in memory. So string changes that. So in the situation with string, now I can say S1 is my string, right? The string that I constructed. And now I can say S1, character 0 or whatever, and change it to lowercase h, right? And then go use cout right here. Let me make more space here and display the string. Cout display S1. Display the string, and sure enough, initially initialized with hello. Now the first character in the string will be changed. I'm expecting this to happen. So if I print this with new line, character in the end, so that we see this output on separate lines. So this prints like, let's print the 0 character here. And we can also print the entire pchar, which is the entire hello string. So this should output hello, this should output uppercase H, and then we say string, let's create a string which takes this as a prototype, but creates a copy of that string, this type encapsulated in a class, and then we display it after changing the first character to lowercase h. So hopefully this will compile. And if I run it, there you go. So there's uppercase hello, uppercase h, and lowercase hello.